All right, so now that you guys have looked over the practice with factoring, we're going to get into rational functions. So that's the unit that we'll mainly cover for the next couple weeks. So we're going to start just today with some introduction to that. So rational functions are of the form f of x equals n of x over d of x. So basically what that's saying is that you have two separate functions, one's on your numerator and one's on your denominator. Both functions, the n of x and d of x, have to be polynomial expressions. That means that you can't have any negative exponents if it's a polynomial. You can't have any fraction exponents if it's a polynomial. You can't have any like square root, cube root, anything like that. Okay, so that's going way, way back to when we learned at polynomial functions and expressions. But you can't have negative exponents, fractions, or square roots in your exponents for either the top or the bottom of that fraction. The other thing too with it being a rational function is it's like a fraction. So you cannot have anything on the denominator equal to 0. That's going to be very important as we work through simplifying and solving rational functions. So we need to figure out what values would give you 0 on the denominator. So some examples and non-examples that we have. Just get rid of that box there for a second. Examples. X squared minus 4 over x plus 2. Totally fine. You don't have any negative exponents, square roots. 6 divided by x, same thing. Your exponents are fine there. For the very first one, h of x would not be able to equal a negative 2. Because if it equals negative 2, that gives you 0 on the denominator, and you can't have that. For f of x can't equal 0. Okay, so if you plug 0 in for x, you get 0 on the denominator, and you cannot have that. Non-examples. So sine of x, that's a trig function. You dealt a little bit with that in geometry. If you take pre-calc, you'll see more of that next year as well. But that type of function is not a polynomial. So that's the key part that makes this not a rational function. And then your second one, you have a square root on the denominator. So because of that, that's not a rational function either. Okay, so if you need to, don't forget you can pause the video just to jot down some more notes or write down these examples. Make sure you have, like always in class too, write down what you need in order to help you understand and grasp these concepts. An undefined expression. So in a rational expression, I'm just going to write this a little clearer so we can see that. N of x over d of x, two polynomial expressions. D of x cannot equal 0. We just dealt with that a little bit earlier. Can't have 0 on your denominator. Since division by 0, or dividing by 0, is undefined, the expression in the denominator cannot equal 0. Any values that make an expression in the denominator equal to 0 are excluded values. Okay, so that's your bolded phrase right here. If you have, let's say, 3 plus x over an x minus 3. Before you do anything with a rational function, you need to figure out what your excluded values are, or what values will give you 0 on the denominator. So to figure that out, you take your denominator, x minus 3, and you set that equal to 0. We're going to solve for x, and you get x equals 3. That is telling you that it's an excluded value. Okay? So if you had 3, and you plug that in for x, you would not be able to actually simplify this because you would get 0 on the denominator. X is not allowed to equal 3, or x equals 3 is an excluded value. Okay, so we've already practiced some of those. You don't need to do all the math and the extra steps in order to solve it. You can probably just look right at the problem. But you will get to a few later on in this unit, I'm sure, maybe even today as well, where you will need to do that extra work on the side in order to figure out all of the values that will give you 0 on the denominator. So for this example, we're just going to find the excluded value or values if they exist. We have f of x equals x plus 1 over x squared plus 3x plus 2. Okay, my suggestion is when you are finding the excluded values is that you get it into factored form. So right now we are going to take this denominator, and we're going to factor it. That's part of the reason why I have so many videos and practice worksheets for you guys to practice and review factoring. So this here is kind of just some extra side work so that it'll make it easier when we go to find all of our excluded values. You are seeing what numbers will multiply to 2 and add up to a positive 3. Obviously, this one here needs to be the one that we're going to factor. 1 and 2 will multiply to a positive 2 and add up to positive 3. So your factors, because this is 1 in the front, just becomes x plus 1 and x plus 2. And we got those numbers from over here in this box. So now that I have that, I'm just going to rewrite my fraction. I'm not worried right now with canceling anything out. Okay, we could technically cancel out that x plus 1, but we'll get to that in a little bit. Right now we're just looking for excluded values, or where your denominator equals 0. So I have two places. I have x plus 1 equals 0 and x plus 2 equals 0. I set those equal to 0 so that I can figure out what value of x will give me 0 on the denominator. So that means I need to solve for x. So my excluded values are -1 and a -2. For either one of those values, if you plug them in, you get 0 on the denominator. Okay, so that's what you have to focus on first before we do anything later on in this unit with simplifying, multiplying, dividing, adding, any of that stuff later on with rationals. Before you do that, you have to find your excluded values. So a rational expression can sometimes be written in a simpler form that's reduced. In order to do that, there are a couple steps that you're going to do. You're first going to state your excluded values. That's number 1. Then you're going to simplify it by canceling out common factors. Okay, the key word here is your factors. That means that you want to get it into factored form. Okay, or do factoring difference of perfect squares, factoring trinomials, anything that you were practicing earlier in some of the videos. Factors have to be multiplied together. Okay, so if we're looking at this example here, 2x squared on the denominator and 8x are not factors because they're being added together. The 2 and the x squared are factors because they're being multiplied. Okay, so first thing that we're going to do is we want to state excluded values, and then we want to cancel out common factors. Just like we did in the previous slide, if you write it in factored form by either taking out the greatest common factor, factoring with trinomials, difference of perfect squares, all of those options, that will help you to identify your excluded values, and that'll make it easier when we go to simplify. So we are going to go ahead and factor. On my numerator, I can take out a 2x from both of those terms. Okay, that's your greatest common factor. When you take out a 2x from the first term, you're left with a 2x. The second term, you're just left with a -1. On my denominator, again, I can take out a 2x. My first term leaves me with just an x, and my second term leaves me with a +4. Okay, now that it's in factored form, we're going to state your excluded values. So every factor, everything that's being multiplied together on the denominator, we're going to set equal to 0. So I have a 2x, then I have an x plus 4. Go ahead and solve those for x. Divide both sides by 2. And then subtract 4 from both sides. So x is not allowed to equal 0 or a -4. Now that we've listed your excluded values, you can go ahead and do the second step. Sorry, I didn't list it up here. By canceling out common factors. So if I look at this factored form here, I can cancel out or cross off the 2x from my numerator and my denominator. So that leaves me with 2x minus 1 over x plus 4. That's the simplest form. There's nothing else that I can cancel. And then I do need to state in here as well that x can't equal 0 or negative 4. Okay? Notice that we needed to do this excluded value of 0 first, because if not, we wouldn't have been able to find it in our reduced form here. Okay? There's no way that you could get 0 in the denominator in this reduced form. But your original problem would have given you 0 in the denominator. So we do need to check those excluded values before we do any simplifying. All right, let's move on to the next slide. Write in simplest form and state the excluded values. Okay, so here's another example. If you're feeling pretty confident, go ahead and pause this video right now. Try it on your own and then check and see if your work matches up with the work that I have. Okay, if you need some more practice and just need to see it, then you can go ahead and watch as I simplify this. So first thing we're going to do is you're going to factor. Okay, notice at the top part that I'm factoring. If you need to do this on the side, go ahead. Seeing what numbers multiply to 1. And then add up to a negative 2. So because it's positive, they either both need to be positive or both need to be negative. My two factors end up being an x minus 1 and an x minus 1. So I'm going to go ahead and write that. And then on my denominator, I can factor out an 8 from both of those, and that leaves me with x minus 1. So now I'm going to list my excluded values. You're only doing it where you have factors with an x in it. Okay, so I don't really need to include that 8 because it doesn't have any x attached with it. The x minus 1 I do need to include. So x is not allowed to equal a positive 1. Now that I've listed that, I can go ahead and cancel out any factors. So I can cancel out this x minus 1. So your reduced form becomes x minus 1 over 8. Can't simplify it any further. And then you need to include that x cannot equal a positive 1. That's it for that problem. Okay? If you got through it and you felt pretty comfortable with it, awesome. If you were stuck, go back and see maybe where you made the mistake for that. All right, another one. Write in simplest form and state the excluded values. Here on the top, you have a difference of perfect squares. So you have an x minus 2 and an x plus 2. Difference of perfect squares means that you have two terms. You have two terms, one where you can take the square root of the first term and the square root of the second. For this second one, okay, it's a trinomial, so you're seeing what numbers here multiply to 6 and add up to a negative 5. Okay, list all your factors if you need to. It's going to be negative 2 and negative 3. Your excluded values. Do this first. So x can't equal 2, and then your other one, x minus 3. Solve it for x, and x can't equal 3. Now you can go ahead and cancel out any common factors. X minus 2 cancels. So your simplified form is x plus 2, x minus 3. And then you also need to state that x can't equal 2 or 3. Okay, I'm going to stop that right here. We have a few more slides. Oh, you guys can read over that. So just your difference between factors and terms. Factors you are multiplying, terms you are adding together. Okay, so look over that if you need some examples. And then if you go to Google Classroom, you will see an assignment, Simplifying Rational Expressions. Go ahead and try that, and I will post the answers. Again, if you need help, log on to Google Hangouts on Tuesday. Have a good day, everyone.